All right, so let's talk through all the information I've got on this table for you here. This is everything we could possibly say. Well, not everything, but a lot of things we could possibly say about our sample. Remember, this is for polling 1,000 people, asking them who they would vote for. 550 of the 1,000 said they would vote for Boebert, and the remaining 450 would say they would vote for other guy. So based on that, we are going to construct what's called confidence intervals, which depends on our confidence level. So depending on how confident we want to be in our findings, we will produce intervals saying, well, we don't know exactly how Nashville will vote as the general population, but we can say to a level of confidence that it should be somewhere between this percent and the upper percent. So for 90%, we got the critical value, which we can get off a table or using technology or using a z-table, where we take, let's see, 90%, that's 10% uncertainty, so zero point 0.1 cut in half to 0.05, and then we do a z-table lookup to find a region of 0.05 or 99.5%. I think both, or 95%, there we go. And then we use that value to find your margin of error. And some of you might be wondering, well, why does it not the negative z-score as well? Well, we use both, really. We use the positive z-score part to go up to the upper bound, and we use the negative portion to go down to the lower bound. So we do use both there. And this process can be done for any confidence level you want. I've done it 5 times, and then I got kind of bored. But you see what happens. Every time we increase our confidence, the critical value goes up, meaning I'm including more and more data to avoid being wrong. My margin of error goes up, and these intervals go up as well. And that's understandable, right? So I got 2 things to say. First of all, based on our sample of 1,000 people, I cannot conclude with 100% confidence that Boebert's going to win. But if you look at this, at the 99% confidence level, Boebert's supposed to get somewhere between 51% of the vote and 59% of the vote. So I can say with 99% confidence that Boebert will win. Now, this does not mean that he's got a 99% chance of winning, which sounds kind of weird. But it just means that our process, such as it was, has a 99% success rate. And it's just, that's a minor difference. And I would like you to see it. But if you don't see it, that's not the immediate stress point here. That's just something that if you get deep into statistics, you will learn to appreciate. At any rate, though, it does look like, we can all agree, it does look like Boebert should win this election. Doesn't guarantee it. In fact, if you look back to the 2016 presidential election, they were projecting that Hillary Clinton had like a 97% chance of winning. Doesn't mean it happened. Anyway, one other takeaway here is that in order to be more confident about your findings, you're going to have to make increasingly vague claims in order to not be wrong. Look here. For the 90% confidence level, it was somewhere between 52 and 57% as far as how much of the vote Boebert was supposed to take. For this 99.999%, it was somewhere between 48 and 62%. For us to be truly at 100% confidence, we would have to say, oh, I think he's going to get somewhere between 0% and 100% of the vote, which is meaningless, useless, but we're guaranteed to not be wrong at that point. And that's just something to think about. But wait. Some of you might be wondering, well, you said we polled 1,000 people, right? How many people should I poll? How many people should I poll to have an appropriate confidence level? And if you think back to the very first day of class, that is something you guys answered on the very first thing you turned in to me. And in the next video, we're going to answer that question. How many people should I poll? I'll see you then.